Welcome to this focused deep dive. Today, we're getting straight into a really detailed research paper on AutoGen.
That's right. It's a framework for building these pretty complex multi-agent systems using large language models.
And we're working directly from the paper itself, which is great. It's packed with architectural details, performance data, the works.
Our goal today, really, is to cut through that detail and understand what AutoGen actually brings to the table for tackling complex problems. We're thinking about this for someone like you who really wants to quickly get up to speed on this significant AI advancements here.
Exactly. And the paper gives us plenty to chew on. We're going to look closely at how AutoGen performs in specific areas. Think tough math problems from the math dataset, complex question answering, using natural questions, navigating those interactive ALFWorld environments.
Right, the decision-making task.
And even code generation, but with safeguards, using something they call OptiGuide.
And beyond just the performance numbers, we'll also, unpack the core design choices behind AutoGen. We need to compare it properly with other things out there, like AutoGPT or ChatGPT with plugins, LangChain 2.
Definitely. The aim is a technically solid, but concise look at what makes AutoGen tick.
Okay, let's dive in.
All right, performance benchmarks first. Math problems, figure 4a. AutoGen, using GPT-4, hits an F1 recall of 66.65% on the math dataset.
Yeah, and what's interesting there isn't just the number, though it's good. It's that this performance is right up there with, and sometimes better than, methods that lean heavily on interactive retrieval.
So the collaboration itself is doing heavy lifting.
It seems that way. It suggests the way these agents work together within AutoGen is really effective for this kind of problem solving, even without constantly pulling in external data like some other approaches.
The baseline AutoGen, without that interactive retrieval, still gets about 26%.
Which is, a decent starting point. But that jump to over 66% really shows the power of the multi-agent interaction. Makes you wonder what specific kinds of math reasoning benefit most from this collaborative approach.
Good question. Okay, moving to question answering natural questions dataset, figure 4b. Here, adding retrieval mechanisms to AutoGen, specifically with GPT 3.5, seems crucial.
Yeah, you see a clear progression. It starts around 54% success without interactive retrieval, bumps up to 69% just adding retrieval augmentation.
And then jumps again quite a bit to 77% when they use interactive retrieval.
Exactly. That ability for agents to sort of refine their search queries as the conversation evolves based on what's needed right then. That seems key.
So it's more dynamic than just a one-shot search.
Precisely. It likely pulls in more relevant information because it's adapting. Figure 4a references DPR with GPT 3.5 getting around 63 per fit 1 recall in another study. So AutoGen's interactive approach looks like it has a real edge for these knowledge-heavy tasks.
Okay, interesting. Now, ALFWorld, that's the language-based decision-making in simulated houses, right?
Yeah, navigating household tasks using language commands.
So figure 4C and the discussion there point to a 3-agent setup in AutoGen. They added a grounding agent.
And that made a big difference. Table 3 shows they hit a 69% average success rate with 3 agents.
Which is much better than the 54% they got with just 2 agents. And better than React, too.
Significantly better. That grounding agent is fascinating. Figure 10 gives an example. It basically provides common sense. It stops the other agents making silly mistakes like confusing finding an object with actually taking it.
Ah, okay. So it keeps things, grounded in reality.
Sort of, yeah. It injects that basic world knowledge. And getting a 77% success rate in a best-of-3 setting with this setup, compared to React 66%, really shows the benefit for these complex interactive scenarios. Raises interesting questions about how best to encode that common sense,
Definitely. All right, let's switch gears to code generation. OptiGuide, figures 4.
This one's geared towards coding tasks needing specific constraints or safeguards.
They used a multi-agent design. A commander, a writer, and a safeguard.
Makes sense. Dividing the roles.
And the user study comparison is pretty stark. They put AutoGen's OptiGuide against ChatGPT with the code interpreter for a coffee supply chain problem.
Yeah.
OptiGuide users finished the task, reportedly, 3 times faster.
Wow, 3.
They needed much less manual intervention, apparently.
That's compelling. It really speaks to AutoGen's strengths when you have specific requirements, maybe private code or specialized tools involved, like the Garobi solver they use.
Right, things that aren't just off the shelf for a general model.
Exactly. AutoGen's workflow seems better suited to integrating and managing those specific dependencies, which leads directly to those time savings and less back and forth for the user. The paper mentions users needed fewer prompts, too. It handles that specialized complexity more smoothly.
Okay, so that efficiency gain is a big plus. Now let's look under the hood a bit. The architecture. What are the key design principles making this work?
Well, the big one is native support for multi-agent collaboration. That's baked in.
Which immediately separates it from something like AutoGPT, which is fundamentally single agent, right?
Right. AutoGen is built for teamwork, from the ground up. It lets you break down problems for different specialized agents. And crucially, it supports dynamic conversation patterns.
Unlike Camel, which the paper mentions has more static patterns.
Exactly. AutoGen agents can adapt how they talk to each other based on how the task is going. More flexible.
The paper also talks about ease of use, modularity. Suggests starting simple, like 2 agents chatting or a group chat.
Yeah, and reusing built-in ways for agents to reply. Plus, that human-in-the-loop approach during development seems important for getting it right.
The feedback from that MiniWabi Plus application they mentioned seems to back this up. Users found AutoGen easier to use, more modular, more programmable than AutoGPT.
And that ties into the dynamic group chat feature, too. That's quite a neat piece of architecture.
Managed by the group chat manager.
Yeah, shown in Figure 12 in A5. It's like having a facilitator agent that decides who speaks next, asks for their input, and shares it with the group.
Enabling a more fluid conversation than just back and forth between 2 agents.
Potentially much more efficient, yeah. And the results seem to bear that out. Tables 5 and 6 show group chat often improves success rates and lower the computational costs compared to just 2-agent chats. It validates that more sophisticated communication structure.
Okay, let's briefly touch on comparisons again. We mentioned AutoGPT's single-agent nature. What about ChatGPT with plugins or the code interpreter?
The OptiGuide example really highlighted the advantage there.
Right.
AutoGen seems better when you need to use private or custom tools and when you want to minimize the amount of manual prompting from the user.
M versus LangChain's React approach.
The benchmarks we discussed, Math and ALFWorld, showed AutoGen performing competitively, often better.
So it holds its own in direct comparisons on specific tasks.
Absolutely. These comparisons really underline AutoGen's strengths in orchestrating that collaborative intelligence. Other tools are valuable, no doubt, but AutoGen's focus on the multi-agent setup, flexible communication, and user-focused design makes it a really powerful platform. The results across these different benchmarks suggest this multi-agent approach offers real advantages for complex problems.
Right. So to kind of wrap up our discussion here, AutoGen comes across as a really robust, flexible framework for building these quite sophisticated multi-agent AI systems.
Definitely.
Its performance across diverse, tough tasks seems strong, and that performance appears rooted in its core design: agent collaboration, dynamic interactions, modularity.
And the ability to integrate things like that grounding agent or specific safeguards.
Exactly. It provides a structured way to explore this whole idea of collaborative AI.
Yeah, it's a structured yet flexible environment. The results really do show the power of getting those multi-agent interactions right. And as this whole field moves so fast, frameworks like AutoGen are likely going to be pretty central to building the next wave of advanced AI applications.
On that note, then, here's something to think about. Given how quickly frameworks like AutoGen are developing, how might these kinds of collaborative AI systems start to fundamentally reshape the workflows and the problem-solving approaches within your own area of expertise? It's definitely something to keep an eye on, especially if you're looking to leverage the real cutting edge of AI development.